Hi everyone. The topic for today is why Gen AI latency behaves really well in testing but fails in production. So, based on developing more than 80 plus such use cases in production, what is actually under the sleeves and what actually works in production? This is the insight that we are bringing over here. And organization, we have done maximum number of production level use cases. So, what actually goes into production? And the phrase that it's very easy to build something related to generative AI, which is POC pilot, but it often fails when it goes to production. This is a very true statement. We're going to see what uncovers here. What is the journey from building something that is, related to POC pilot and what goes into production, right? And the segment over here is latency. That's what we are going to target here. Why something behaves really, really well in training or testing perhaps and really fails in production. The answer is overfitting. Some or a different format of overfitting exists when things don't work in production, right? And here it's perhaps a little more nuanced and innocent than it actually is in machine learning. Machine learning, it is a very straightforward sense of overfitting. Here you are not, completely aware about what exactly is going wrong in the latency areas. So if you have to define, let's assume that if I want to define latency or for any random problem here, the latency is a curve. It's a mathematical curve. In case of LLMs, it depends on these three different areas. It depends on what is the context you're giving in, what is the intel, what is the reasoning that LLMs are doing in, and what is the context that LLMs are giving out. If I just have to talk about a complete system latency over here, these are the three segments this latency depends on here, right? And in production, why this fails is one of the core reason is production is noisy. The production data is really noisy. And you don't have a limitation on size. You don't have the limitation on how many people would be using, perhaps. And training data or testing data is something. It's very predictable. It's something that you have already seen. But production is something that you have never seen. It's something that it's an uncharted territory, to be really honest. But how do you make system, right? Because that's the goal. How do you make system that works well in production, right? We know all this constraint. It's noisy. The data keeps on increasing. But how do you kind of build a system that really works well in production? So these three segments, let's remember this complete curveball of latency. The first curveball of latency is context in. The second curveball of latency is context out. And the middle layer is the reasoning layer, right? These are the three factors that affects latency. And I'm going to take one example for the context sake. I'm going to take an example of, Max Healthcare. It's a healthcare-based organization for which we developed a doctor assist system, which used to understand doctor's query, quickly fetches from the entire set of data, quickly fetches, kind of what are the relevant sets of data, fetches the input out, formulate it, create some sort of data insights, and give it back to the doctor. So this is the system that we're going to take as a reference, right? So just as again for the reference, the query comes in, it converts into a SQL, it plans and fetches the data out, understands the data, create a data insights, and give it back to the user. This is the flow that it is there. So three areas that affects latency here is that, okay, when you're talking about training or testing, you're talking about a limited set of universe. You are talking about a limited set of time period, right? Things are time bound. But when you go to production, there's nothing like time bound. It can be 5 years, it can be 3 years, it can be 4 years, it can extend on, whatever system goes up to that stage, right? So data keeps on appending by themselves, right? Latency directly gets affected by that. Your system might not be able to, it's not designed to handle 10 GB of data. It's designed to handle perhaps only few MBs of data, right? But production goes and kind of handles 10 GB of data. So for example, we are talking about, let's assume that in this particular case, we are talking about lab-based values, right? So whenever lab test happens, we store all of those lab-based values and that we fetches when we are talking about data insight. While we were building the system, we were only considering for the last 6 months or last 3 months or 4 months, which any developer while building systems would consider. But when it goes to production, the data came across to be more than, kind of lab values of more than 3 years, 4 years, 5 years. That actually started behaving a little odd when it comes to latency. Then comes the multi-turn conversations. So, what exactly we mean by the multi-turn conversation? So it means this: any system, whether it's a RAG-based system or it's a chatbot system or it's a data insight system, it's your MCP-based system, any system in this world that is dependent on generative AI only works well when there is a context. It's a context-dependent problem. It's not a model problem; it's a context problem. It all depends on what is the context that's flowing in. With increasing sets of number of sessions. With every increasing session, there is a new context that gets added, and that's a new insight that gets added, right? In training data set, we have not considered about it, right? Whenever training data sets happen, usually this part is avoided, where you don't consider, okay, you definitely do consider for your session gets stored, you get imported, but you never considered, okay, this would increase and this would again start affecting my latency curve, right? That level of detail is usually avoided when you are building a testing or training data set for this kind of situation, right? But every new conversation session would increase, chat history would increase, the context window would increase, and that would start affecting my production. This is two. So what we have covered a long context accumulation where, the natural progression of the data itself gets increased. That would increase my context size by default, by fundamental. Second is that multi-turn conversation where, due to session storage, or perhaps due to every new conversation, chat sessions get started increasing. So that started increasing. So this is two areas. What is the third area is perhaps one of the most kind of nuanced or more talked about area, where it's the reasoning effort, the throughput. So now we have covered both of these areas where, the size of the context increases, and that is a direct correlation with increasing the latency. But when you talk about reasoning models or LLMs in general, they also works on throughput. What is throughput? Throughput is the amount of work that's being spent on one token. That is what throughput is. So the more noise it is there in the data, the harder it becomes to handle the prompt. The tougher is the reasoning efforts that is attached to it. Involved, more throughput increases, and perhaps it increases the latency. And production data is noisy, and then with more noise, the reasoning gets increased a lot, more validation gets increased, and all of that stuff happens. Your throughput increases, and perhaps increases your latency. All right. So again, targeting three major problems what we discussed about, that is, your context, natural progression of data increases, your context increases, and perhaps your prompt, the reasoning token gets increases, whereas your overall token input and output might be similar, but your reasoning token gets affected. Okay, now let's talk about solution. So solution that has actually worked by experimenting with such, odd 40 to 50 such different use cases, right? What has actually worked in production for us is designing at scale, is pipeline. What has solved software industry, or perhaps any industry, is a pipeline. It's a process. Here also we are going to do the exact same stuff. Why there is a difference between software engineering and LLMs or AI engineering? Here is software engineering, everything is very well defined. From set A to set B, you get a very structured input, structured output, structured input, structured output. The flow is very constant. But when you talk about generative AI in general, the flow is stochastic in nature. It's all haywire. There is no guarantee that this is what you're gonna get out. And even if you don't get, there is no guarantee of what went wrong to debug it over here. But these are problems. We need a solution, right? So solution is that with every layers of stochastic, we are gonna add something which is deterministic, right? We are not gonna reinvent the wheel. We are gonna do what we already know the best. That is a very deterministic layer of function calls, API integrations, parameter to parameter. But the intel here at every different stage is gonna plugged in via LLMs. So that's what we're gonna do. So the way to do it is, right, so let's address the first problem, right? The first problem is, how do I ensure that context remains as equivalent as we need? So I'm gonna do something that is called context slicing over here. So that is something that actually works really well in production. That is that you don't need to feed all the data in. You only always need a context slices of very relevant chunks of the data. So you do that, you pre-process that into timelines, you pre-process that into very relevancy of the context, that usually a lot of these data which are very bad data is not very relevant for that prompt. So the whole idea is that you build kind of a guardrails around this data. You kind of create something that's very relevant for the scenarios, right? You don't feed in noise. So there are exact filters that you are putting here, that no noise actually goes back into the production, right? So for example, we're talking about production environment is there. There exists a set of prompts. So you put a set of high signal data, that only something which is very relevant for this particular use case, only that gets filtered out. It's a very deterministic layer, and that gets fed into LLM here. At every stage, we define a very structured output. Solve your 60 to 70% problem. When you're designing specifically with the multi-step functions, that is something that solves your 80% of the problem when you have everything well defined. Structured output gives you, this is exactly what you want a behavior of your LLMs. And then there is some sort of, rolling summaries of the context. So whenever, to address session based problems, right? Whenever the second problem that we discussed, that with more number of session, more chatting gets increased is, so the whole idea is that you never need to present the whole raw inputs always add a, kind of systematic layer that creates a summary and only passed a very, summary of only 200 words that has a very fixed context of 200 words, and only that needs to be passed over here, so you exactly know what you're feeding over here. So the systems that fails in production are those systems where everything is not parameterized, right? The whole idea is to parameterize everything over here, kind of understand where, kind of there are rolling summaries that we're gonna add to the context area. We implemented as GoML in this particular solution. We implemented, team understood that, kind of we face these issues where our context window was expanding haywire, where, the queries that doctors were asking, or perhaps physicians were asking, were something that we have never seen. Because when we design system, we design for a set of universe, right? And when it happens in production, it happens for something that you have never encountered or never visualize for, that something sort of this might come across, right? And this kind of scenarios happen. So how to deal with that is, you maintain a, how perhaps our team designed a solution for this is that they started maintaining a caching layer. What does this caching layer does? It says, okay, first time I might not exactly know how to solve this, but with moving sets of iterations, I'm gonna start caching these responses in. These are the different sets of question repository, and that works really well with any kind of query response system. That you maintain your query repository or FAQ repository, you keep appending to it, right? What has worked and what is the set of responses. This single more serves as an inspiration for next set of LLM responses. So, the whole idea is that you cover the complete universe, right? One universe is that what you have already defined your training data set. One universe is what is an actual production universe, and that you keep on appending on whatever your learning systems have been across to. So, just to summarize everything now, so latency is usually in 90% of scenarios is never a model problem. Latency is always a context problem. Your production system, your latency system, your cost constraints, your all these different constraints have a very subjective solution. What we touched upon today is a very affecting production based solutions in a different base. So yeah, in next episode we'll break down how we design bounded interference paths. So cost parts. So today we covered the latency, but next we are trying to cover the cost areas of production environments, how they're gonna ensure that cost stays intact. If it resonates well with you, visit goml.io and book a conversation with us. Thanks a lot.